Hello, welcome to the series of CASTEP. We are at the lecture number 8, and this series basically I briefly discussed about CASTEP parameters. Here from this icon when we click on calculations, we get the interface of CASTEP calculations. Here we have different types, setups, electronics, properties, job controls. In our previous lectures I briefly discussed about setups and electronics. Here we have more option in electronics. By clicking on more option we get this type of interface. We have bases, FC, FO, K points, potentials. In our previous lectures I talk up to potential table. In this lecture I will discuss about DFT+D corrections. When you come to this interface you get this type of interface. By clicking on customize checkbox we can customize parameters. I will go through explain one by one. So here we have different schemes of DFT+D correction parameters. Basically if you want to learn what is DFT+D corrections, and standard DFT like LDA, GGA parameters does not describe weak van der Waals forces. So to capture these dispersion forces, which is very important for molecular crystals, layer materials and adsorption, etc. So through these parameters from this step you can include DFT+D corrections. I mean you can include weak van der Waals force for your calculation. Okay, so a DFT+D correction we can define to allow or to apply dispersion correction scheme in your calculations, and the purpose of this parameter is add van der Waals force which is missing, which will miss in LDA and GGA parameters. So you can add from here. Okay, so we have different schemes here: TS, GRIME, OBS, MBD. So these are different schemes of DFT+D corrections. Okay, like TS is environmental dependent, widely used, more which is more accurate for most of the calculations. GRIMES is for D2 or D3, which is also very simple and which is mostly used organic molecules. And OBS is a older scheme which is less common use nowadays, and MBD is one of the another scheme for DFT+D parameters. The next thing is atomic parameters, in which we have atoms C6, R0, alpha. Through atomic parameters we can define parameter for each atoms to get van der Waals parameters. Like C6 is the dispersion coefficient, which is basically the strength of van der Waals force interactions. R0 is basically van der Waals radius. This is basically through this you can adjust the distance scaling. And the third one is alpha, which is basically for polarizability, which is related to electronic response. And here we have scheme parameters from SR. This SR is basically scaling of van der Waals radius. Through this you can adjust closed atom must be before van der Waals interactions. And the last one is basically D, which is damping parameters. This is for controlling short range behavior to avoid doubling count with DFT exchange correlations. From here you can reset your parameters according to CASTEP. When you select scheme, so from here your C6 and R0 values and S6, these all are adjusted automatically by CASTEP. Okay, and from here you can manually change your parameters. So if you have any literature about, you can manually adjust your parameters. Okay, after that DFT+D corrections, we have another type of CASTEP calculation, which is property. From here you can calculate different properties of the material like band structure, core spectroscopy, density of state, electron density difference. We have different options: optical property, orbital bonds, and stress, etc. Here when you click on band structures, so for band structure energy range should be selected, should be defined, and cap points should be defined, and here the separations will be known. In more options we have CASTEP band structure options. Use replace CS function for band structure calculations. So if you want to replace the exchange correlation functions, from here you can adjust, okay, and you can change the band energy tolerance from here. So you have options for, particularly if you want to change these parameters, so you can adjust from more options, okay. After that we have another tip with a job control. From here you can adjust, you can control your job with your PC, name of the PC, and from here you can give scores of your processor for calculations, and here we have 3 different running time optimization, default, memory, and speeds. So it's depend on you which one calculation you want to calculate. If you want to just check, click on speed option. If you want to give formation to CASTEP, so do on default. If you want to calculate more accurate, give more memory of your PC for calculations, so click on memory option, okay. So these all about the parameters of CASTEP. After that I will discuss about how to calculate the single point energy, how to calculate geometry optimizations, dynamics, elastic constant, and how to calculate different properties of the material through CASTEP.